Okay, let's unpack this. When you think of artificial intelligence, um, your mind might jump to futuristic robots, right? Or smart home devices, maybe. Or perhaps the latest advancements in, generative AI that can write text or create images.
Pretty amazing stuff, yeah.
But what if I told you this cutting-edge technology, often seen as just like a purely digital force, is actually making some incredibly tangible strides in saving our physical planet?
Hmm. It's a surprising connection for many people, I think. One that truly reshapes how we view AI.
Definitely. Today, we're embarking on a deep dive into the fascinating and often contradictory role of artificial intelligence in environmental protection. On one hand, AI is being leveraged in these groundbreaking ways to combat climate change, reduce pollution, promote sustainability. Across a dizzying array of industries.
It really is. It's acting almost like a digital defender, giving us tools and insights we never thought possible before.
Exactly. Yet, on the other hand, AI itself comes with its own substantial and frequently overlooked environmental costs, a significant ecological footprint that we absolutely need to understand.
That's the crucial part.
Our mission in this deep dive is essentially to give you a shortcut to understanding this complex, dual nature of AI. You'll walk away well informed about what is truly a double-edged sword, armed with surprising facts and critical insights into both its immense potential and its significant pitfalls.
Hmm.
We'll explore exciting breakthroughs like how AI is tracking deforestation or helping to clean our oceans, right alongside the pressing concerns such as its massive energy and water consumption. Get ready to have your perceptions challenged because this is a story that impacts all of us directly and indirectly.
It really does.
So let's start with the good news, right? All the incredible ways AI is stepping up to protect the environment. It's truly remarkable to see how a technology so often associated with abstract data and algorithms can have such profound and positive effects on the ground, in our air, and in our oceans.
It's striking, isn't it? It's striking to observe how AI's ability to process truly vast data sets and then identify complex patterns often hidden to the human eye, is fundamentally changing our approach to environmental challenges.
Fundamentally changing.
Yeah, this isn't just about minor improvements. It's about transforming tasks that were once deemed, well, impossible, or at least prohibitively slow and expensive for human analysis alone, transforming them into achievable, scalable solutions. This represents, really, a paradigm shift in how we understand and interact with our planet's intricate ecosystems.
A paradigm shift.
Okay.
And a particularly critical area where AI is making a profound difference is in the global fight against deforestation. Expert, when we talk about the loss of forests, what's the scale of the problem we're truly up against, globally, and why is it so hard for humans to track this effectively?
Well, it's an immense problem, just
Right.
staggering. The United Nations estimates that 10 million hectares of forest are cut down each year.
10 million hectares.
Every single year. To give you a sense of that scale, it's roughly equivalent to losing an area 17 times the size of Los Angeles annually.
Wow. That's hard to even picture.
It is. And this isn't just about the loss of, beautiful trees. It devastates precious ecosystems, pushes countless species closer to extinction, and critically dramatically increases global carbon emissions. The sheer expanse of forests and the remote nature of many logging operations just make human monitoring alone incredibly difficult, almost impossible in some places.
Right. You just can't be everywhere at once.
Exactly. And this is precisely where AI steps in with these dual capabilities, both detection and prevention.
Okay. Detection and prevention.
For detection, researchers and companies are pairing AI with high-resolution satellite imagery, creating these highly sophisticated mapping tools. A Scottish company called Space Intelligence, for instance, has successfully used this method to map over 1 million hectares of land across 30 different countries.
1 million hectares.
And this isn't simply about seeing where deforestation has occurred. It's about precisely tracking illegal logging practices, even in the most remote areas, and generating critical awareness that can, spur action.
So it's getting eyes where we couldn't before.
Precisely. But we can't just react after the fact, right? The true power of AI here also lies in its predictive models.
Oh, the prevention side.
Exactly. These models analyze a multitude of factors, things like historical land use patterns, projected infrastructure development, population density, and they use all that to identify areas at highest risk of deforestation before it actually happens.
That's incredible. So it's like an early warning system for forests.
Kind of, yeah. This proactive approach gives conservationists, governments, policymakers a critical, almost anticipatory advantage. It allows them to lead targeted conservation efforts and intervene where support is most urgently needed. The real insight here, I think, is how AI transforms conservation from just a reactive battle to a proactive intelligence operation. It lets us anticipate and prevent loss on a scale never before imagined. It fundamentally changes the strategic fight for our planet's vital forests.
It's remarkable how AI moves from simply observing a crisis to actively predicting and preventing it.
Yeah.
That's huge. Now, from protecting the planet's lungs, AI is also diving into its circulatory system, our oceans, to tackle the growing crisis of plastic pollution.
Another massive challenge.
Absolutely. The statistics on this are frankly overwhelming. The Ellen MacArthur Foundation projects that by 2050, our oceans could actually contain more plastic by weight than fish.
Just think about that for a second. More plastic than fish.
It's hard to fathom, and consider this. An estimated 85% of all plastic waste simply ends up in landfills.
85%.
And it's thought there are 21,000 pieces of plastic floating in the ocean for every single person on the planet.
21,000 pieces per person.
Expert, how can AI possibly get a handle on a problem of such staggering scale?
Well, that's the central challenge, isn't it? And it forces us to ask, how does AI handle the sheer volume and variability of pollution data
Yeah.
that would just completely overwhelm human analysis?
Right.
The answer is that AI thrives on this kind of complexity. It's making plastic recovery on land and removal from oceans significantly more efficient. On land, for example, CleanHub has integrated AI into its software to automatically review data during the waste collection process.
How does that work?
So when a collection team logs an entry, with photos and details, the AI software flags inconsistencies, ensuring data integrity and safety. This includes checking for image compliance, like identifying bare hands or feet to make sure workers wear proper safety gear. And that feature has actually led to increased shoe wearing among workers, which is great,
Oh, that's an interesting side effect.
isn't it? It also flags image weight mismatches between, say, the visual evidence and the manual entries, and data weight outliers for unexpected weights. All of this ensures transparency and accuracy in the collection data, which is vital for effective, scalable programs.
Got it. So it cleans up the data collection process itself.
Exactly. Then, in the oceans, organizations like the Ocean Cleanup are using AI with satellite imagery and autonomous boats to map plastic pollution in vast areas like the Great Pacific Garbage Patch.
Yay, I've heard about their work.
They can create these detailed, precise maps of where the ocean litter is concentrated, making cleanup efforts far more targeted and effective than just, guessing where to go.
Makes sense. Directing the resources properly.
Precisely. And it's not just mapping. Researchers at the University of California, Berkeley, have even developed an AI-equipped robot.
A robot.
Yeah, with a camera and a suction system that can swim through the ocean and actively collect plastic debris underwater.
Wow. So robots literally cleaning the ocean.
It's happening. The profound insight here is that AI provides practical, scalable solutions where human effort alone would simply struggle. It transforms an otherwise, frankly, insurmountable global challenge into one with tangible pathways to resolution.
It's truly inspiring to imagine robots actively cleaning our oceans. Okay. We've seen how AI helps manage living systems like forests and oceans. Now let's turn our attention to the man-made systems that also bear a heavy environmental cost. Industry.
A huge source of emissions.
Right. Industrial sectors generate around 30% of global greenhouse gas emissions. Expert, what's the scale of industrial emissions we're talking about, globally speaking, and how is AI making a difference across such a diverse range of operations? It seems like a huge, complex area.
It is huge and complex. And from a broader perspective, this isn't just about small tweaks to industrial processes. It's about a fundamental shift in how entire industries operate, with AI as the central orchestrator of efficiency.
The orchestra.
Yeah. Global CO2 emissions are currently over 35 billion tons annually. That's a massive leap from just 6 billion back in 1950.
35 billion ton.
Decarbonizing these sectors quickly is a huge undertaking. And AI is proving instrumental here by making existing systems smarter, more efficient, tackling emissions from multiple angles.
Okay, so multiple angles. Like what?
Consider supply chains, for instance. These are incredibly complex networks, right? AI analyzes them to optimize everything from transportation routes to warehouse logistics. This helps improve energy efficiency, reduce packaging waste, minimize inventory levels. Pendulum, for example, uses AI to help organizations predict demand and plan supply.
And that reduces waste.
Exactly, which is critical when you realize that an estimated $562 billion is lost annually just due to overstock. That leads to significant product waste and associated emissions.
$500 billion in waste. Wow.
Their AI can even process unstructured data from complex manuals for things like precision agriculture, ensuring optimal resource use in farming.
Okay, so supply chains, farming. What else?
Then there's building efficiency. AI monitors and controls building systems like HVAC, that's heating, ventilation, air conditioning, and lighting. It even assesses occupancy patterns to optimize energy usage in real time.
So turning off lights in empty rooms, but much smarter.
Much smarter, yeah. Brainbox AI, for example, uses autonomous AI to optimize HVAC systems in commercial buildings. They're seeing up to a 25% reduction in HVAC energy costs and up to a 40% reduction in related greenhouse gas emissions.
That's significant savings.
It really is.
Mhm.
And what's more, their use of generative AI, the kind that can analyze and generate documents, significantly reduces building onboarding time by over 90%, but automatically extracting data from technical manuals. So it speeds things up too.
90%, that's fast.
We also see AI assessing transportation methods for route planning, traffic management, fleet optimization, factoring in everything from real-time traffic to fuel consumption, even suggesting alternative modes of transport.
Right, optimizing delivery routes and things like that.
Exactly. And finally, AI algorithms analyze vast amounts of data from energy systems to optimize generation, distribution, and consumption. This plays a pivotal role in the transition from fossil fuels to cleaner, renewable energy sources by making the existing infrastructure run as efficiently as possible. The core principle here really is that AI acts as this overarching intelligence, making every component of our industrial infrastructure more sustainable by optimizing for maximum efficiency and minimal waste.
That's a truly comprehensive approach to emissions reduction across entire sectors. Very powerful. But beyond daily operations, AI is also giving us a critical edge in preparing for and preventing climate disasters.
Which are becoming more frequent, unfortunately.
They are. Expert. The number of climate-related disasters has actually tripled in the last 30 years. Floods, droughts, hurricanes, heat waves, monsoons, they're becoming more frequent, more intense, taking a devastating toll on communities globally. How does AI help us anticipate these increasingly unpredictable events?
Well, it's really a matter of critical assurance, isn't it? And trust in our models to make timely decisions, potentially saving countless lives and resources. AI's predictive power here is just phenomenal. These models process vast amounts of climate data, far, far more than any human team could possibly sift through to identify patterns that are often beyond human capacity to detect.
Patterns we wouldn't even see.
Exactly, thereby dramatically improving predictions for these extreme weather events. This means governments, emergency responders, policymakers, they can develop much better disaster preparedness plans and optimize resource allocation with greater confidence. The UN Secretary General's early warnings for all initiative, for instance, relies heavily on AI to ensure everyone is protected from hazardous weather by the end of 2027.
So it's a key part of global initiatives.
Absolutely. And we see companies like Brazil Supremo already using AI to predict climate disasters for industries like insurance, energy, logistics, helping businesses and governments better prepare.
What about vulnerable communities?
That's crucial. UN agencies are using AI to investigate past environmental change around displacement hotspots, places like Burundi, Chad, Sudan, to provide future projections. This helps vulnerable communities adapt and plan for potential migrations or other impacts. My colleague Jim Bellingham from Johns Hopkins emphasizes AI's vital role in understanding our oceans. They're arguably the least understood part of Earth, but they transfer and absorb immense amounts of heat, profoundly impacting global weather patterns.
Right, the oceans drive so much.
They do. And AI-powered robots, for example, could operate autonomously for months in really challenging environments like the Arctic, especially during winter when traditional observation methods are just impossible. They can fill crucial data gaps, improving our understanding of how these critical areas are changing.
So robots in the Arctic gathering data.
Yeah. The insight here is how AI enhances our ability to essentially see into the future of our climate, giving us that crucial lead time to protect vulnerable communities and infrastructure. It transforms reactive emergency response into proactive resilience building.
Improving our understanding of vast, complex systems like the oceans is absolutely crucial. And speaking of understanding, AI is also simplifying the complex task of tracking air pollution.
Another major health issue.
Huge! Expert, this is a massive public health issue. Air pollution is the largest environmental threat to human health worldwide, contributing to an estimated 8.43 million premature deaths annually, according to the WHO.
8.4 million.
Why has traditional tracking been so challenging, and how does AI cut through that complexity?
Well, traditional tracking has been incredibly time-consuming and data-intensive
Mhm.
because of the sheer number of variables involved. You've got traffic, weather, industrial emissions, geographical features, topology.
Right, everything interacts.
It's like trying to solve a puzzle with millions of pieces constantly shifting. Cornell University engineers, for instance, have developed a simplified AI algorithm. It uses inputs like traffic data, the shape of the land topology, and meteorology to simulate traffic-related air pollution scenarios.
Okay, so it builds a model.
Exactly. And this allows city planners and government health officials to gain a much better and quicker understanding of local air quality. It's about transforming complex, raw data into actionable insights for public health officials, enabling them to make informed decisions that directly impact the health of their communities, often at a hyperlocal level.
So targeted interventions become possible.
Precisely. This really highlights AI's power to make invisible threats visible and manageable, allowing for targeted interventions that genuinely save lives.
This ability to distill complex data into actionable insights is truly a hallmark of AI's power. It's also revolutionizing how we handle waste, specifically plastic recycling.
Back to plastics.
Yeah. The OECD estimates that only 9% of the world's plastic is actually recycled. 9%.
It's shockingly low, isn't it?
It is. That's a global issue crying out for more efficient solutions if we want to move toward a truly circular economy. How is AI tackling this challenge in the sorting and recovery process?
Well, the recycling industry is genuinely being revolutionized by AI. It's improving sorting and recovery dramatically, pushing us closer to that idea of a circular economy. We're seeing innovations like smart recycling bins, for instance. These are AI-powered, using sensors and cameras to detect waste types.
Smart bins?
Yeah. WasteNet, for example, achieved an impressive 97% accuracy rate, classifying waste into 6 distinct categories: paper, cardboard, glass, metal, plastic, and, others.
97% accuracy is pretty good for a bin.
It's very good.
Yeah.
Then, in larger recycling facilities, London startup Grey Parrot has developed an AI system that analyzes incoming waste streams. Get this. It tracked an astonishing 32 billion items across 67 waste categories in 2022 alone.
32 billion items.
32 billion. This data helps facilities recover and recycle far more material than traditional manual sorting ever could.
I can imagine. That's a lot of data.
And perhaps most visually striking are the recycling robots from another London-based company, Recyclin.
More robots.
More robots. They've designed a robotic picking system specifically for sorting dry, mixed recyclables. They currently have 30 AI-powered robots contracted across the UK, Ireland, and other parts of Europe, with 19 already installed and working.
So robots are actually picking through the trash now.
They are. These robots can identify and sort materials at speeds and with an accuracy that humans simply cannot match, especially in challenging, sometimes hazardous environments. The critical insight here is that AI brings this new level of precision and automation to waste management. It makes the previously inefficient and often dangerous process of sorting waste dramatically more effective and scalable,
Right.
thereby unlocking the potential for a truly circular economy.
It's impressive to see robots literally getting their grippers dirty in the fight against waste. Staying with consumption patterns, AI is also stepping in to reduce the massive environmental impact of the fast fashion industry.
Ah, yes, fast fashion.
This sector produces an astounding 92 million tons of textile waste each year. 92 million tons.
That's mind-boggling.
And if you've ever returned an online order, you're contributing to another problem. E-commerce returns account for up to 24 million metric tons of CO2 emissions annually.
Just from returns.
Just from returns.
Yeah.
How is AI helping to unravel this complex knot of overproduction and wasteful consumption?
Well, that's a significant burden on the planet, isn't it?
Yeah.
And AI helps us connect the dots on how to lighten it. Primarily, AI optimizes inventory management and predicts sales based on sophisticated historical data analysis.
So better forecasting.
Much better forecasting. This is absolutely key to preventing brands from overstocking clothes and sending perfectly good but unsold materials straight to landfills or incinerators. By having a more precise, granular understanding of demand, companies can produce more efficiently, tailoring supply much more closely to actual consumer needs.
Less guessing, less waste.
Exactly. And to address those e-commerce returns you mentioned, which are a huge source of emissions due to packaging, shipping, and often the eventual disposal of returned items, AI try-on solutions are emerging.
Virtual try-ons.
Yeah. Companies like the prescription eyewear retailer Warby Parker or Amazon use these virtual solutions. They allow customers to digitally see how clothes or items fit without ever needing to order and return them physically.
Ah, I've seen those.
They significantly reduce the need for physical returns, directly cutting down on the associated emissions and waste. The insight here is that AI can influence both production and purchasing habits through smarter technology, creating a more responsive and less wasteful industry, really from the drawing board all the way to the customer's closet.
That's a brilliant application, tackling waste at both the production and consumption ends. Really clever. Finally, let's look at how AI is supporting the monumental transition to renewable energy.
A critical piece of the puzzle.
Absolutely. Expert fossil fuel consumption has increased eightfold since 1950, driving climate change. The challenge with renewables like solar and wind, of course, is their intermittency. The sun doesn't always shine, the wind doesn't always blow.
The age-old problem.
Right. This intermittency has hindered their wider adoption in the past, often requiring fossil fuel backup. How is AI helping us overcome this fundamental hurdle?
This is where AI truly acts as an enabling capability for a net carbon zero economy. It directly addresses that core issue of energy stability for renewables. And AI isn't just a new player here. It already serves over 50 different uses within the energy system today.
50 uses already.
Yeah. One of its most crucial roles is in improving supply and demand predictions. AI uses highly complex weather models combined with specific turbine location data for wind farms, for example, to forecast wind power output much more accurately.
Better weather forecasting, essentially, but for energy.
Exactly. This gives researchers and grid operators a much better real-time understanding of when renewable power is likely to fluctuate, allowing them to anticipate and plan much more effectively.
Okay, so prediction is key. What else?
Furthermore, AI algorithms are instrumental in determining the best times to store energy. Energy storage is a key challenge for the industry, right? When do you charge your battery banks, and when do you release that energy back to the grid?
Right, optimizing the batteries.
AI analyzes pricing signals, demand forecasts, generation predictions, all of it, to optimize those storage and release cycles. By optimizing when energy is generated, when it's stored, and when it's consumed, AI helps integrate intermittent renewable sources into the grid more seamlessly and reliably. The overarching insight here is that AI provides the intelligence necessary to make inherently variable energy sources predictable and manageable. It accelerates our shift away from fossil fuels and makes a truly resilient, renewable energy grid a reality.
Okay, so AI sounds like a superhero for the planet, doesn't it?
Yeah.
I mean, it's tracking deforestation, cleaning oceans, decarbonizing industries, predicting disasters, improving recycling, streamlining fashion, bolstering renewables. The list goes on.
It's an impressive list, for sure.
But here's where it gets complicated. It's not all sunshine and optimized energy grids. There's a darker side to AI's own environmental footprint that we simply cannot ignore. It's not just a tool, it's also a consumer of vast resources itself.
And this raises that important question, doesn't it? While AI offers incredible solutions, we absolutely must critically assess its own environmental impact. It's truly a double-edged sword, and understanding both sides is crucial for responsible deployment.
It's a double-edged sword.
We need to look at the massive resources it consumes just to exist and operate resources that have very real planetary consequences. The profound insight here, maybe, is that the very digital infrastructure designed to optimize our physical world is simultaneously creating this kind of invisible environmental burden, pushing us further into a resource-intensive future that current policy and energy grids are often ill-equipped to handle.
An invisible burden.
Okay.
And the biggest contributor to that hidden cost is carbon emissions, right? The energy hunger.
Absolutely.
Expert. The energy hunger of AI, particularly for training and running those massive large language models, LLMs, the sophisticated AI models capable of generating human-like text, like those powering systems you might be familiar with, such as ChatGPT. It's just immense.
It really is.
OpenAI reports that the computing power required to train AI models has doubled every 3.4 months since 2012, every 3.5 months.
That's truly exponential growth.
It sounds like an alarming trend.
It is indeed an alarming trend. And that exponential growth comes with an equally alarming energy bill. A single large AI model, just during its training phase, can produce an estimated 283,948 kilograms of CO2.
Wow. Can you put that in perspective?
To put that into perspective for you, that's roughly equivalent to about 300 return flights from New York City to San Francisco.
300 flights for one model training.
Or nearly 5 times the lifetime emissions of an average car, just for the training. We've seen specific examples that illustrate this. BERT, A prominent language model trained back in 2019 required the energy of a round-trip transcontinental flight. GPT-3, a much larger model, during its training, released about 552 metric tons of CO2. That's equivalent to 123 gasoline-powered passenger vehicles driven for an entire year.
123 cars for a year.
And even more recent, supposedly more efficient models like Bloom, well, it initially released 25 metric tons of CO2 during training, which sounds better. But then their carbon footprint essentially doubled to around 60 flights between London and New York when you factor in the energy cost of manufacturing the highly specialized chips themselves.
Ah, the manufacturing cost is key too.
It highlights that the embedded energy in hardware is a significant, often overlooked part of the equation.
Right, so it's not just running them.
Exactly. But it's not just the one-off intensive training process either. Inference costs, meaning the energy used for each query once a model is trained and running, also add up rapidly.
So every time you ask ChatGPT a question,
Basically, yeah. A single ChatGPT query, for example, uses about 5 to 10 times more electricity than a simple web search. OpenAI's Sam Altman stated a ChatGPT query uses about 0.34 watt-hours of electricity. Now, when you multiply that by millions or even billions of daily queries globally,
The numbers get huge fast.
the cumulative numbers become absolutely staggering. And the problem extends to the infrastructure supporting AI. Globally, data centers, the physical homes for AI computation, consumed 460 terawatts of electricity in 2022.
460 terawatts.
To give you some context, that would make them the 11th largest electricity consumer in the world. They consume more than entire nations like Saudi Arabia, almost as much as France.
Wow, more than Saudi Arabia.
And this immense and rapidly increasing demand from AI is having a direct, observable impact on our energy grids. In places like Kansas City, West Virginia, Salt Lake City, this demand is actually pushing back the scheduled closing of coal-fired plants because existing grids just struggle to keep up.
So AI demand is...
In some cases, yes. In Northern Virginia, a major hub for AI data centers, facilities are facing delays of up to 7 years just to get high-power grid connection.
11 years.
The corporate impacts are also stark. Google's greenhouse gas emissions, for example, increased 48% in just 5 years, directly attributed to their growth in AI operations. This caused them to miss their own net zero goals. Microsoft and Meta have reported similar, significant increases.
So the big tech companies are feeling this.
Absolutely. So what does this all mean for you? It means the convenience and power of AI that we increasingly rely on come with a very real, very large energy bill that the planet is currently footing. This situation also vividly illustrates Jevons paradox, that economic principle where efficiency gains are often offset by increased usage.
Right, the rebound effect.
Exactly.
Okay.
It means that even if AI models become more energy efficient, if we use them more frequently and for more applications, the overall environmental impact could still rise or maybe even accelerate.
That's a truly sobering thought. The energy hunger of AI is immense. But it's not just carbon emissions that demand our attention. Expert AI also has a surprising and substantial demand for another critical resource: water. These machines are incredibly thirsty, apparently.
They certainly are.
And in a world increasingly facing water scarcity, this seems like a collision course.
It really does, and this raises that fundamental question. How can we truly balance the promise of AI with the very real demands on our planet's finite resources like water? The servers running AI models generate a tremendous amount of heat, just constantly.
Right, computers get hot.
And to prevent overheating and maintain optimal performance, elaborate cooling systems are necessary. Many of these systems rely on evaporating vast amounts of water in cooling towers. And this water, once evaporated, is essentially lost from the local water cycle.
Lost to the atmosphere.
Quantifying this usage is quite shocking. It's estimated that AI data centers could consume enough water to fill 2,500 Olympic-sized swimming pools per year.
2,500 swimming pools.
Per year. A recent paper projected that AI could withdraw between 4.2 and 6.6 billion cubic meters of water globally by 2027. That's more than half of the UK's total annual water withdrawal.
More than half the UK's water use, just for AI.
Projected, yes. And to make it more relatable, consider this. Every 20 to 50 ChatGPT questions you ask consumes about 500 milliliters of water. That's roughly the size of a standard bottle of water.
Wow, a bottle of water for a handful of queries.
And the training of GPT-3 alone, may have consumed an astounding 700,000 liters of water.
700,000 liters.
We're seeing this directly impact major corporations and local communities. Microsoft's water consumption, for example, increased by 34% due to its AI operations. A proposed data center near Phoenix, Arizona, in an already water-stressed region, remember, could consume 56 million gallons annually. That's the water footprint of about 670 families.
In Phoenix, that's tough.
Similarly, Microsoft's Iowa data center cluster accounted for 6% of a local town's freshwater use. Google also increased its water usage by 20% due to AI.
So it's a real strain on local resources.
Absolutely. Solutions are being explored, of course. Some companies are building data centers in colder climates. Meta has one in Luleå, Sweden, for example, and Google's campus in Hamina, Finland, uses seawater for cooling, which can mitigate freshwater demands.
Using cold air or seawater makes sense.
Another approach is adopting closed-loop cooling systems that reuse water, significantly reducing overall consumption. However, the core challenge remains, especially in regions already facing water scarcity. The insight here is that as our digital world expands, its physical footprint, particularly its thirst for water, becomes an increasingly critical environmental and social concern that demands strategic planning and innovation beyond simply finding cooler climates.
The demand on water resources is a critical, often unseen impact of AI. But there's another looming problem that our digital world is generating: e-waste.
The digital landfill.
Exactly. Expert, our reliance on technology is creating a rapidly expanding digital landfill, and AI is poised to exacerbate it significantly. Globally, we already generate about 62 million tons of e-waste annually. That's the weight of 5.6 million double-decker buses.
62 million tons.
And less than a quarter of it is properly recycled. What will AI's contribution to this mountain of waste look like?
Well, this is a truly concerning trend, isn't it? And it urges us to consider the full life cycle of AI infrastructure, really, from the mining of raw materials all the way to the eventual disposal of hardware.
Cradle to grave. Or cradle to cradle, hopefully.
The World Economic Forum projects that by 2050, the total amount of e-waste generated will surpass 120 million metric tons annually. AI could add an additional 1.2 to 5 million metric tons of e-waste by 2030 alone.
Up to 5 million extra tons just from AI.
Representing potentially up to 12% of global e-waste. This significant contribution comes from several factors.
Like one.
Firstly, the sheer volume of specialized hardware required for AI, particularly powerful GPUs, those graphics processing units, and custom AI accelerators, is growing exponentially. And these components tend to have shorter lifespans as newer, more efficient generations are constantly developed and adopted.
Faster upgrade cycles mean more old stuff.
Precisely. Secondly, consider the raw materials needed for this hardware. Making a single 2-kilogram computer requires an estimated 800 kilograms of raw materials.
800 kilos of materials for one laptop.
It's staggering. Microchips, which are at the heart of AI computation, need rare earth elements, often mined in environmentally destructive ways, with significant energy and water costs. The rapid growth and, frankly, planned obsolescence of AI hardware means these expensive and resource-intensive devices are deprecated faster than ever. This leads to a hazardous waste stream that contains toxic chemicals and valuable metals.
So it's toxic waste too.
It often is. Now, while it's a problem AI directly contributes to, ironically, AI itself can offer some mitigation strategies. We discussed robot recycling earlier from companies like Recycleye, right?
Right, the robots sorting waste.
AI-powered machines sorting waste with high efficiency. AI can also enhance collection and segregation processes for e-waste, making it easier to identify and recover valuable components for reuse or proper disposal. But the critical insight here is that our pursuit of advanced digital intelligence is creating a substantial physical waste problem. It underscores the need for a circular economy approach that designs hardware for longevity, repairability, and recyclability from the outset.
Designed for reuse.
Rather than simply hoping AI can clean up the mess it helps create later on.
That full life cycle consideration is absolutely vital. And here's perhaps the most contradictory and concerning point in AI's environmental impact. It's not exclusively supporting renewables or environmental cleanup. Expert, AI is also being used to accelerate fossil fuel extraction, directly intensifying climate change. This seems like a direct conflict with all the green applications we just discussed.
It does, doesn't it? And if we connect this to the bigger picture, this is precisely where the societal choices about how we deploy AI become absolutely critical.
The choices we make.
Yeah. It highlights the urgent need for careful ethical consideration and clear policy guidance on how we allow this powerful tool to be used. AI is a technology, and like many powerful tools, its impact depends entirely on the hands that wield it and the objectives they pursue.
The intent matters.
Hugely. Consider Shell, for instance. They recently announced plans to use generative AI to speed up oil and gas exploration. Their stated aim is to improve safety, efficiency, and sustainability within their operations.
But faster exploration means
But the fundamental outcome of applying such advanced technology in this context is accelerated fossil fuel discovery and extraction. This is a very direct application of AI to deepen our reliance on carbon-intensive energy sources. AI solutions provider Spark Cognition claims their machine learning algorithms can find previously untouched fossil fuel resources on the ocean floor in as little as 9 days, a process that historically took 9 months or more with conventional methods.
9 days instead of 9 months.
This application highlights the dual nature of AI in a very stark way. A technology with immense potential for good, capable of solving pressing environmental problems, can also be leveraged to exacerbate the very climate crisis it's helping us solve in other domains. The insight here is that AI is a powerful enabler. It amplifies existing intentions. Without careful guidance and ethical guardrails, its efficiency gains can equally serve environmentally damaging industries. It underscores that technological advancement alone doesn't guarantee a sustainable future.
Right.
It's the choices we make about its application that truly matter.
So what does this all mean for us as we move forward? It's clear that AI is a powerful force, but its direction isn't set in stone. Expert, how are governments and companies around the world grappling with these challenges, balancing AI's immense potential for good with its growing environmental footprint?
Well, knowledge is most valuable when understood and applied, right? And this raises that important question. How do we ensure AI is harnessed for good and its negative impacts are mitigated through conscious policy and design? The policy landscape is, frankly, still in its nascent stages. It's really trying to catch up with the rapid pace of AI development. Governments are aware, generally speaking, but the solutions are complex and varied.
Okay. What about the U.S., for example? In the United States, there's a real lack of comprehensive federal legislation specifically addressing the environmental impact of AI. As of November 2024, the Artificial Intelligence Environmental Impacts Act of 2024, introduced by Senator Ed Markey, was the only federal bill. It proposed studies and voluntary reporting, but it wasn't reintroduced in the current Congress.
So no federal law right now.
Not specifically on this. So much of the action, or perhaps inaction, has been left to state initiatives.
And we are seeing some action there, notably in Virginia, which, as we mentioned, has become a major data center hub. The state has been considering legislation requiring data centers to report their water and energy usage, reflecting growing local and regional concerns.
So transparency requirements.
Potentially. One bill proposed a mandatory review process for large data center developments exceeding 100 megawatts, but it was voted against primarily due to concerns it might deter significant economic investment. It's a tricky balance.
The jobs versus environment argument.
Often, yes. However, another bill, House Bill 2035, aims to require quarterly reporting on water and energy use to the Department of Environmental Quality, making that information publicly accessible. These are initial, localized steps, but they powerfully highlight the ongoing challenge of balancing economic development and technological growth with essential environmental stewardship. The insight here is that policy is often reactive, isn't it? Struggling to keep pace with rapid technological shifts leading to these fragmented approaches.
Fragmented, yes. What about Europe? Are they approaching it differently?
In contrast, the European Union is taking a more comprehensive, sort of integrated approach. Their European Green Deal explicitly aims to use AI and other information and communication technology, ICT, for broad sustainability goals. They've also developed the Green Deal data space, which is designed to aggregate cross-sectoral environmental data. The idea is to allow AI to find patterns and advise policymakers more effectively.
Using data for policy.
Exactly. Ethical reports from the EU advocate for AI systems to consider their environmental and social impact from the outset, and they explicitly call for assessing environmental risks within the groundbreaking European AI Act.
So it's built into their main AI law.
The intention is there, yes. Policy recommendations from various EU bodies include things like restricting market access for AI systems that fail on emissions monitoring, mandating efficiency improvements, industry-wide sustainability reporting, and comprehensive life cycle assessments.
That sounds quite thorough.
It's ambitious, Moreover, individual EU member states are actively developing their own national strategies. France, for example, prioritizes sustainable AI design, the rigorous publication of ecological data related to AI, and supporting AI for efficient grids and renewables. Germany's national AI strategy includes dedicated sections on environmental impacts, funding AI research for energy efficiency, the circular economy, resource management, and contributing to the UN Sustainable Development Goals. They've even disbursed over 70 million euros through their AI Lighthouses program, specifically for environmental AI solutions.
70 million euros just for green AI.
And Italy also advocates for government-backed stimulus in AI for sustainability research and application. So if we connect this to the bigger picture, regulation and policy are trying, often playing catch-up, with the rapid pace of AI development. It highlights the critical need for foresight and international cooperation, something that's always a challenge with emerging, globally impactful technologies.
That diverse policy landscape shows that governments are certainly starting to recognize the issue, even if they're moving at different paces. But beyond policy experts, what are the actionable strategies for companies and organizations to adopt and develop AI responsibly? How do we ensure it truly becomes a net positive for the environment, tipping the scales toward a sustainable future?
Well, what's fascinating here is that the solutions often involve AI itself becoming more efficient or facilitating efficiency across entire industries. Got to create a virtuous cycle, potentially.
AI helping itself be greener.
In a way, yes, but it truly requires collaboration and targeted investment. AI offers crucial cross-cutting capabilities, like precise global monitoring of CO2 and methane emissions. This allows us to attribute emissions to specific facilities and prevent fugitive emissions, those accidental releases from pipelines or industrial equipment. AI's ability to simulate new materials could lead to transformational breakthroughs, like replacements for structural steel, which is an incredibly carbon-intensive material to produce.
Finding cleaner material.
Exactly. Large language models could even accelerate energy permitting by rapidly drafting and reviewing documents, or quickly building power flow models for renewable transmission interconnects. This could drastically speed up the deployment of much-needed clean energy infrastructure.
Cutting through red tape, basically.
Potentially, yes. Recommendations from groups like the ICAF AI for Climate Mitigation Roadmap highlight concrete steps. Organizations working on climate should actively explore AI opportunities and build AI skills within their teams. Governments, businesses, philanthropies should fund collaborative forums where AI experts and climate scientists can jointly develop solutions. Companies holding climate-relevant datasets should seriously consider public sharing to foster innovation. And there needs to be dedicated funding for large-scale open-source foundation models tailored specifically to climate challenges.
Open source for climate AI. Interesting.
We're seeing corporate commitments too. Amazon, for example, has committed to net zero carbon by 2040 and aims for 100% renewable energy for its vast AWS data centers by 2025. AWS also provides specific guidance for optimizing generative AI workloads for sustainability, recognizing that the efficiency of their services directly impacts their footprint.
So corporate responsibility is part of it.
A huge part. And efficiency improvements in AI development are constant and critical. Remember, even AI models with lower energy costs can have huge cumulative footprints if run millions or billions of times daily. This emphasizes the need for continuous improvements in model architecture and hardware. Companies like VIA are developing compact, open-source, large language models that can run on more energy-efficient CPUs rather than demanding power-hungry GPUs. They also use hot swapping to integrate newer, more efficient models as they become available, making the models themselves leaner. Exactly. They also provide privacy-preserving data analysis using zero-knowledge proofs. It's a clever way to verify information, like energy usage in buildings, without actually revealing the sensitive underlying data itself, which is crucial for privacy and security, right?
Right. Privacy is always a concern.
So these strategies, from conscious policy to sustainable design principles and robust collaboration, are absolutely key to tipping the scales towards AI being a net positive for our environment.
This has been an incredibly eye-opening deep dive into the dual nature of AI. Really has. We've seen that it offers truly transformative solutions to some of our planet's most pressing environmental problems, from safeguarding our forests and cleaning our oceans to decarbonizing industries and speeding up the transition to renewables.
The potential is undeniable.
But we've also squarely faced the reality that AI's inherent demands for massive energy, vast amounts of water, and the rapid generation of e-waste create a whole new set of environmental challenges that we are only just beginning to grapple with. It is unequivocally a powerful tool, a true double-edged sword that cuts both ways.
Absolutely.
Ultimately, the future impact of AI on the environment depends on conscious, informed choices made by the developers creating these sophisticated systems, by the policymakers setting the rules and incentives, and indeed by us, the consumers who demand and use this technology every day.
It involves everyone.
It does.
So as AI continues to evolve and become an even more pervasive part of our lives, the question isn't just what can AI do, but maybe what should AI do? And how will we collectively ensure it truly serves the planet rather than burdens it? Well, what stands out to weigh about how we navigate this powerful technology's complex role in our environmental future?